In this video, you will learn how to calculate the enthalpy of the reaction by using bond energy. Let's try with an example. How do we synthesize water? We can use H2 plus O2 and give us water molecule. When we balance the equation, it looks like this. So how do we calculate the enthalpy of the reaction? Well, by using Hess's law, I can find the enthalpy of formation of the product multiplied by 2 minus, well, I guess that's all, because elemental form over here and the formation enthalpy will be 0. So that's one way. So one way is using the Hess's law. However, there's another way of approach. Now, I'm going to draw the molecule here, H2. So I have two of this. I have one molecule, I have two molecules, and I put oxygen, O2. How do I know how much energy will be released? Here is how it goes. We can assume that hydrogen will absorb certain energy. When it absorbs the energy, the bond can break. So over here, we can break all the two bonds over here and become 4 of this. So I need to absorb the energy to break these two bonds. And also, I need to absorb the energy to break the OO bond. So now I have O and O. So what happened is I already absorbed the energy over here, break this bond, and break this bond. Now, I would like to recombine these all. So what happened is 2 of the hydrogen will combine with an O. So once this one, when it combines with oxygen, it releases energy. When it combines with H, it releases energy. So now this equation now is releasing the energy. Again, combining, releasing energy and releasing energy. So what we are doing is we try to see how much energy is needed to break up all the bonds in the reactant and how much energy will be released by forming the bonds in the product. In other words, the reaction of the enthalpy should be equal to the energy that is absorbed to break the bonds in the reactant minus the energy that is released by forming the bonds in the product. If we put that into a mathematical formula, it will look like this. Delta H of a reaction will be equal to the energy that used to break the bonds, and then minus the energy that needs to form the bonds. In other words, this one will be the energy to break the bonds in the reactant. Over here, it will be the energy to form the bonds in the product. Okay, let's look at an example. I'm looking at problem number 14 now. Let's look at this one. Over here, here are the reactant, and this is the product. So what is the delta H for the reaction? Our old way is we try to find out the formation energy of this one and then minus the sum of the formation energy of the product. Of course, this one will multiply by 2. That's one way of doing it. But since we don't have that chart in front of us, what's in front of us is the energy to break the triple bond, the energy to break the CH single bond, and the energy to break the HI single bond, energy to that release when forming CH bond, CC bond, and CI bond. According to that formula, let's do that. That will be the sum of the energy to break bonds in the energy to break bonds in the reactant minus the sum of energy released that forms bonds in the product. Okay, so let's get started. Over here, I have to break a triple bond. So how much energy I should absorb? I should absorb in kilojoules per mole, I should absorb 839. Okay, what else should we break? We should break this CH bond, So CH bond is over here. So plus, we need to break 2 of the CH bond, that's 413. Okay, what else do we need to break? We have 2 of this, HI. So we have to break 2 of the HI bond, that is 299. Okay, let's see what is forming. So we just minus whatever that is forming. Okay, minus the sum of this. So we are going to form a CC single bond. So that's 348. We are going to form 4 of the CH bond. So plus 4 times CH bond will be 413. And we are going to form 2 of the CI bond. So plus 2 times 240. Times 240. Okay, so let's use our calculator and see what we get. I have 839 plus 2 times 413 plus 2 times 299 minus the sum of 348 plus 4 times 313 plus 2 times 240. What I get is negative 217. The unit will be kJ per mole. Okay, so over here, this will be your answer. Okay, let's do another exercise. Okay, we are working on problem number 15 now. Okay, using the table of average bond energy below. So this is given. Find the enthalpy of reaction. Okay, so we are going to do the same thing. So over here, we are going to break 1 CC triple bond, 2 CH single bond, and we are going to break 1 HI single bond. Over here, it's not very obvious, so I'm going to write it down. This one is C, double bond C. Over here, you see the H2, that means H over here, H over here. Over here, you see H and I, that means H over here, and I over here. So for this molecule, how can we form this molecule? We have to form a CC double bond. We have to form 3 of the CH single bond, and we have to form a CI single bond. So let's do it. The energy of the reaction, energy, will be equal to the sum of the energy that breaking the bonds, minus the sum of the energy that forms bonds. And we know that this must be in the product, and this must be in the reactant. Okay, let's do it. The energy that needs to break the bond over here, I have to break 1 CC triple bond, and that is 839, 839. kilojoules per mole. And I have to break 2 of the CH bond. So I plus 2 times CH bond is 413. So I put 413 over here. I also need to break the HI bond over here. So I plus HI is over here, 299. Okay, so that's all the energy is required to break the bonds. Minus, I'm working on this part now. Over here, I am forming a CC double bond, and that is CC double bond is here. It is 614. I am forming 3 of the CH single bond, so plus 3 times CH single bond is here, 413. I also form a CI single bond, so plus 240. I find it from here. All right, so let's use my calculator. It will be 839 plus 2 times 413 and plus 299 minus, remember to put the parentheses, 614 plus 3 times 413 and plus 240. So from my calculator, what I get is negative 129. The unit will be kilojoules per mole. So this will be the correct answer.